Let's talk about a technology that's on the verge of completely rewiring, well, the entire physical world. It's called quantum computing, and it is about to ignite a revolution in one of the most ridiculously complex systems we've ever built, global logistics.
I mean, let's be real for a second. Our global supply chains are stretched to the absolute limit. We've all seen just how fragile they can be. And the reason is pretty simple, actually. The complexity has just exploded. The fix isn't about just making our current computers a little faster. No, it's about inventing a completely new kind of computer, one that's built for exactly this kind of chaos.
Okay, so let's really get into this. To understand why we need such a radical new solution, you first have to appreciate the massive scale of the problem. Why exactly are our logistics systems at a breaking point?
It's basically a perfect storm of factors, right? You've got ongoing labor shortages, you've got these wild, extreme weather events that can shut down ports and roads with zero notice, and of course you have those huge shifts in demand that the pandemic just kicked into overdrive. Now, any one of these would be a major headache, but when you put them all together, you get a level of complexity that our current way of computing just can't keep up with anymore.
And this image, wow, it shows you that the problem isn't just in one place. These challenges are literally stacked on top of each other. You have the day-to-day stuff like, what's the most efficient route for this one delivery truck? Then you zoom out to the medium-term decisions, like where to position your fleet of trucks. And then you zoom out even further to these huge strategic questions, like where should we build our next warehouse? Today's computers look at these things separately, in their own little boxes, but in the real world, they are all connected.
So, how do you solve a problem that has almost infinite variables and connections? Well, you fight complexity with a new kind of complexity. And this is where the hero of our story comes in. A new kind of computing that runs on the strange but incredibly powerful rules of quantum mechanics. So, what's the big difference here? Honestly, when you boil it down, the core idea is pretty simple. Your phone, your laptop, everything runs on what we call classical bits. A bit is just like a light switch. It's either on or it's off, a 1 or a 0. That's it. But a quantum bit, or a qubit, that's more like a dimmer switch. It can be all the way on, all the way off. Or, and this is the key part, it can be in a mix of all the states in between, all at the exact same time. This whole dimmer switch thing has a name. It's called superposition. And that is the secret sauce. Because qubits can exist in many states at once, a system of them can explore a truly mind-bending number of possibilities all at the same time. So, instead of checking one delivery route, then the next one, then the next, a quantum computer can look at a huge landscape of possible routes all at once.
So you see, this isn't just about getting a faster answer. It's about asking a totally different type of question. Quantum computers are being designed to find the single best answer from among trillions of options, a task that is literally impossible for even the biggest supercomputers on the planet today.
Okay, so that's the theory. But what does this actually look like in the real world of trucks and ships and cardboard boxes? Let's check out 3 real-world examples where this is already starting to happen. 1,200. I want you to remember that number. It's not random. It's the number of stops in a single real-world logistics problem that has already been tackled with this brand new technology. So IBM worked with a vehicle manufacturer on this exact problem, finding the best delivery routes to 1,200 different spots in New York City. They had to account for really tight 30-minute delivery windows and the specific capacity of each truck. For a normal computer, the number of possible combinations is just insane. But by using a hybrid quantum approach, basically letting a classical computer do the easy stuff and then handing off the hardest part of the puzzle to the quantum computer, they found a better solution and cut the total cost.
I absolutely love this quote. It comes from an IBM report, and it just perfectly tees up the next, and maybe even more powerful use case: what happens when things go wrong?
You know, our systems today are pretty rigid. If a port shuts down because of a storm, the computer reacts based on a simple list of pre-programmed rules. But a quantum computer, it can proactively run thousands of different what-if scenarios. What if there's a storm, a labor strike, a parts shortage? It can figure out the impact across the entire network. So when a disruption actually happens, the system doesn't just react, it executes the best possible recovery plan, one it already found from a sea of possibilities. And we're not just talking about trucks in a city anymore. The same ideas apply on a global scale. Huge companies like ExxonMobil are already looking into how quantum can solve massive shipping problems for things like liquefied natural gas. I mean, these are puzzles with so many variables, weather patterns, market demand, the size of your fleet, that today's computers can't actually find the perfect answer. They just guess. Quantum promises to deliver an actual, optimal answer. Okay, I know what you might be thinking. At this point, quantum computing can sound a little bit like magic, right? A solution for everything. But, like with any game-changing tech, it is so important to separate the hype from what's actually happening today. So, let's do a quick reality check.
This quote from a very recent academic paper on the topic is key. And they're right. We are absolutely still in the early innings of this game. So, what does early stages really mean in practice?
It means we're in what experts call the NISQ era. That stands for Noisy Intermediate Scale Quantum. Noisy means the qubits are still pretty fragile. Tiny changes in temperature or even vibrations can throw them off. Intermediate scale means we don't have millions of perfect qubits working together yet. And that's exactly why almost all the solutions we see today are hybrid. They cleverly use a classical computer for the heavy lifting and then pass the most ridiculously hard part of the problem over to the quantum processor.
But, and this is a big but, early stages does not mean things are standing still. Just look at this chart. It shows the number of research papers published on quantum computing just for logistics. Look at that curve. The explosion of interest and research just since 2020 is, well, it's staggering. The momentum is for sure there.
So here's the real takeaway. Even while the technology is still growing up, the time for businesses to start paying attention is right now. You really don't want to get caught flat-footed when this quantum leap finally arrives.
And you know, there's another, much more urgent reason to be paying attention. The same power that can optimize a supply chain could also break the encryption that protects that supply chain. A powerful quantum computer could theoretically just shatter the security that protects everything from your bank account to sensitive shipping data. This has kicked off a global race to create what's called post-quantum cryptography, new defenses for a totally new world.
So, just how seriously are business leaders taking all this? Is it still just a thing for scientists in a lab? Well, a recent survey of global tech leaders gives us a pretty big clue. 35%.
That's right. More than a third of tech leaders expect to start bringing quantum computing into their actual business operations as soon as next year. This isn't science fiction anymore. It is quickly becoming a strategic business decision. And that really brings us to this powerful final thought from IBM. The choice isn't really if this technology is coming. It's about what side of the equation you're going to be on when it gets here. A wait-and-see approach is a huge gamble in a race that's already well underway. So, we'll leave you with that question to think about. The pieces are moving on the board, the research is accelerating, and the first real-world applications are already up and running. The quantum leap is coming. The only real question is, will you be ready for it?